Welcome to Ask and Learn.
Hey everyone, Alex B here with a question on electric resistance from Chapter 25 of G. Colley's Physics for Scientists and Engineers. So the question asks us, if we have a copper wire with a diameter of 2.2 millimeters, can we have the same resistance from a tungsten wire of the same length? Now, to answer this question, we just have to look at the equation for the resistance of a wire. R, the resistance, is equal to rho, a resistivity that's a property of the material, times length divided by area. Rearranging this a little bit, we see that for a given length, L, all we need to do to keep the resistance the same is to keep rho over A, the resistivity divided by the area of the wire, a constant. So yes, of course we can have the same resistance from the same length of wire, even if we make it out of a different material. All we need to do is make sure that rho over A is a constant. Now, plugging in numbers into this, what we need to find is, given the resistivity of tungsten, which we know, what area A sub T of tungsten do we need such that we keep this the same as it was for the copper case? Rearranging this, we find that all we need is to keep the area of the tungsten wire equal to the resistivity of tungsten over the resistivity of copper times the area of the copper wire. Now, we're not actually given the areas of the wire, but we are given the diameters. And all we need to do to convert the two is know that area is equal to pi times d over 2 squared for a circular wire. Plugging this into our above equation, we find that pi times the diameter of the tungsten wire divided by 2 squared is equal to the resistivity of tungsten over the resistivity of copper times pi, the diameter of the copper wire, over 2 squared. Now a lot of things here are obviously going to cancel out. Pi and the 1/2 are going to cancel out on both sides of the equation. And solving just for the diameter of the tungsten wire, d sub t, we should find that it's just going to be the square root of the resistivity of tungsten over the resistivity of copper times the diameter of the copper wire. Plugging in numbers given to us by the book, we find that the resistivity of tungsten is 5.8 times 10 to the minus 8 ohms per meter, ohms times meter, sorry. And the resistivity of copper is 1.68 times 10 to the minus 8 ohms times meter. Here I'm dropping the units because they just cancel out here. And we know that the diameter of our copper wire is going to be 2.2 millimeters. Plugging in these numbers, we find that we need a diameter of tungsten wire of 4.0 millimeters, where I've rounded to 2 significant figures because that's the number that they used in the problem.